Hello, this is Mr. Collier, and today we're doing tautologies and contradictions. Alright, so if we look at the definition first of all of tautology, it's a compound proposition that is always true, regardless of the truth values of the individual propositions. So basically, your last column is going to be all true, and then that's a tautology. Okay, so show that the compound proposition P or not P is a tautology. So let's do that. So we need to set up P and then not P, and then we'll figure out P or not P and see what happens. So actually there's only two possibilities, true, false for P, and then false, true, and then the or statements are only false if both of them are false. So these are both true. And when you get everything to be true in the final column, or the answer, you get what we call a tautology. Okay, next example. Show that the compound proposition P then, if P then P or Q. Okay, if P then P or Q is a tautology. Alright, so let's work that out. So we're going to do P and then Q, and then we're going to have P or Q, and then we're going to have our final compound proposition is if P then P or Q. Alright, so let's fill up the truth tables here. True, false, true, false, false, true, false, false. So P or Q is only false if both of them are false, and the rest of them are true. And then here, remember, for an implication, it's only false if the first one's true and the second one is false. So if we look at, and we're looking at, remember now, we're looking at this column and this column. So we're looking for this one to be true and this one to be, look for P to be true and P or Q to be false. So P is true, and do we see a false? No. So we don't have a TF, we don't have a true implies false, so then there's no false basically. Everything else is going to be true. So that shows that we have a tautology. Okay, so that's a tautology. Now let's look at what we call a contradiction. So contradiction is kind of the opposite of that. We have, we're going to get always false, so your final column is going to be all falses. So show that the compound proposition P and not P is a contradiction. It kind of makes sense. You can't have P and not P at the same time. It's going to be a contradiction. So if P and not P, okay, so P is going to be true, false, and false, true. So P and not P is only true if both are true, so these statements are both false. When you get all falses, you get what's called a contradiction.